Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's program is astrophotography. And our special guest to talk about this exciting topic is Tom Harbin. Tom, welcome to the program.
Thank you. Thank you very much for having me. Glad to be here today.
Great. Well, before we get into the nitty-gritty of the topic, why don't you tell our audience a little bit about yourself?
Well, my name is Tom. I'm also known as the Astro Canuck on social media and online. And I've been dabbling into astrophotography for the better part of almost going on 5-6 years now. But I am a graphic designer of 20 plus years. I've always been interested in combining a sort of design and astronomy in an interesting way. And it's kind of been my passion for years of learning more about outer space as a kid, always growing up, reading like National Geographic, seeing all the awesome images, and just kind of moving on from there to actually realize that you can take images of outer space with a backyard telescope, which I didn't know until 4 or 5 years ago. And yeah, I spent some time in the United Kingdom for about 10 years and gathered a lot of experience over there, and finally moved back to Canada a couple of years ago, and just kind of doing what I can to share my little corner of the cosmos with everyone.
Great. Now, we're going to get into the astrophotography gear, and we'll start out with automation. Why is that a good thing?
I think it's a good thing because it really allows people to get into astro imaging or even just visual astronomy without a lot of the complications that can come into star hopping and trying to find a certain target. Because it's also great to tour around the night sky. That's fantastic. But there's also that level of frustration that can come along with it when people will think that you'll look through your telescope and you'll see these images that you get in the magazines and you see online. And it can almost be instantly disappointing for some people if they have those really high expectations. But I think for the automation to be able to have a telescope be able to align itself relatively quickly, and when you say point to this target, it's going to go to that target. You'll look at it or you'll image it, and at least you're kind of on the way to seeing something really cool, producing an amazing image that you want to share with friends. And I know there's a lot of there can be some people of the of earlier generations perhaps that are thinking, well, we had to suffer for all of this, you have to suffer as well. But I think it kind of you need that balance. Like, I have used automatic go-to telescopes, and I've used manual systems, and I think the manual systems are great for learning the night sky. But again, to say I want to look at the Ring Nebula, and the telescope will point over to the Ring Nebula. I mean, we don't have voice control yet, but punching in the coordinates. Because there's one time I went to look at the Ring Nebula, and I was out with a friend, and I said, "Hey, look, we found the Ring Nebula." We looked through the scope, and we're like, "Oh, that's awesome! That looks so good." And then I realized the telescope was really out of focus, and I was just looking at a very defocused star. Later on, we found the Ring Nebula, but it was just that one thing of it was just manually pointing. I figured that's got to be it. It wasn't it.
Oh my. So yes, the automation can get you there quickly, and then of course with the tracking keep you on the target so that you can gather your images. Now, once you've done that, you need to have some software to help process these images, correct?
Yes. There's a lot of software out there that you can utilize, and there's a lot of free software you can download. I started off using the Deep Sky Stacker to at least align and stack all the images so we can get a better a better view of what we're taking a picture of. And it's one of those things. It's free, it's easy to access, and I've always now for kind of processing more of the images, I've used Photoshop. It's kind of one of the things that I've used for decades. And there's other software. Photoshop is better designed for like terrestrial photography. It's designed for editing images that we take on with great lighting situations. As far as editing for astro imaging, Photoshop, we need to bend it to our will, which I gotta say, I'm happy with how much my skills have increased in processing images. But there are other programs out there that are going to allow you to process images that are designed for it, like PixInsight, AutoStacker, if you're doing planetary imaging. And those are all designed with space in mind, so that we can actually get a better result with the images. Because Photoshop, you can start telling to erase certain pixels, and it's really like maybe a little bit of a star cluster, and then you get rid of that in the image. So that's where utilizing the software that's proper for astro imaging. But with that also comes like a brand new learning curve. And for a lot of people, that can be daunting. Me, myself, I tried using PixInsight, was relatively happy with the results, but I spent a lot of time away from it, and I got to like relearn it all over again. So it's kind of keeping at it. But that can also be tough if you're inundated with a lot of clouds and you don't get a lot of data to work with.
Exactly. Of course, the one thing with clouds, if you have a lot of data, then you have the time to work with that data, and you're not thinking, gee, I could be outside imaging.
This is true, especially even when you get like those surprise clear nights. It's like, oh, I could have been out imaging, but now I'm in bed.
For sure. Now, we talked about automation and how you can get to something quickly. How about other time-saving devices that you use?
Time-saving device for me, the absolute. Now, this is just this is a lot of personal experience. The best little tool that I've found, especially if you're one person who's going to bring you're moving your rig a great deal, or kind of bring it in and out if you don't have any proper protection for the outdoor elements, is a pole master. It is a little camera that you can set in the polar axis portion of the of your equatorial rig, and you can be polar aligned in a couple of minutes. Whereas if you were kind of looking through the rear side of the Polaris finder, and you need to find out exactly at what hour Polaris is sitting at in the reticle, and making sure that everything is lined up properly. At least the automatic, the electronic version with the Pole Master it's been a great time saver for me, and I felt that in the end the alignment was much better, especially when you're shooting at longer focal lengths. I've done manual polar alignment with the Skywatcher Star Adventurer, and it freaked me out a little bit because my very first night I like nailed the polar alignment. I'm thinking, did this really happen? It's like so many people talked about it being like a big problem, a big stepping stone to moving into an equatorial mount. But it was what kind of saved me is at least shooting at much wider focal lengths for those star trackers. But it's one of those things, unless you just got to keep doing it, keep going over and over and over. But at least with the Pole Master, I found it's fantastic to get that quick polar alignment, and then you're just off to imaging. You're confident with that alignment.
Well, sure, much quicker, I would think, than doing the drift method that we all got used to doing decades ago, I guess now.
I tried that once.
And?
I tried it once. That was about it.
Enough said, I guess. All right, well, I understand that you do live streaming on Twitch. Can you enlighten us about that little adventure?
Yes, it started off as, for those who are not familiar with the Twitch platform, it can popularly be known as a place where people will play video games. And I kind of thought that initially as well, where I really kind of started sharing my own feed from my telescope. Actually, I didn't even have a feed to the telescope, but it's held my camera up to the computer screen and shared images on Facebook. realizing that there was a little bit more of an interactive platform that was available with Twitch, where you could speak live with viewers and have those one-on-one interactions. It was a place where I had heard of someone else doing astro imaging, and they were out in the United States. And I figured, let's give it a try. Let's see if I get everything hooked up to my computer. It was during the lockdowns in the United Kingdom and during the rise of the pandemic. So there wasn't a whole lot I was going out to do. So I figured let's get this all together. And it started off very, very slow because, again, it's not a platform where you're expecting to have any kind of educational science-related content. But I've been doing this for the past almost 2.5 years now, and it's a much wider base of science within astronomy, geology, paleontology, to people who are sharing their knowledge with others for free. It is a free platform to sign up and watch it on. And over the 2.5 years, we've witnessed some amazing things on the channel, and I'm grateful for a community that we've built to just consistently share these experiences with astronomy, and other people join in who are astrophotographers themselves, and we all have different stories we like to share, sharing the frustrations that could come with new equipment, or when something just suddenly stops working with no warning and you got to run through all of the troubleshooting. But it's what I enjoy doing, and yeah, that's streaming online as Astro Canuck has been very rewarding for what I started doing that I didn't think would really do anything for a guy streaming out of his kitchen in the UK for a while.
How can our viewers find you on Twitch?
If you just search for Astro Canuck, that's my name across all the platforms. So that's on Twitter, on Instagram, Facebook. Although Facebook is the Astro Canuck. I went for the definite article there because somebody parked Astro Canuck ages ago. I'm still trying to get that one.
All right, well, this has been an interesting conversation so far, Tom. We're going to take a quick break. To our viewers, if you have any questions, please send us an email. As always, the address is down at the bottom of your screen. And coming up next is Term of the Month with Stephen.
Thanks, Don. The term of the month is aging slower. I do something with computers for a living. The new toy is ChatGPT, an artificial intelligence chatbot. You can type at it and it responds with pretty decent sounding stuff. 2 groups tested it with astronomy questions. In both cases, ChatGPT responded with good sounding answers that eventually go wrong, while continuing to sound confident. In a discussion at the office, the question came up, do you age faster in orbit or on the ground? I got the wrong answer. Yay! There are 2 relativity effects. One is for speed and one is for gravity. Both slow time down. Astronauts orbit at 17,000 miles per hour, and time is slower by 9 microseconds per day. Gravity is stronger on the ground, and time is slower there by 45 microseconds per day. So the orbiting person experiences time 36 microseconds faster than the ground person per day. Now, in 2016, twin astronauts Scott Kelly and Mark Kelly participated in medical experiments with Scott in orbit and Mark on the ground. An article on it in 2 web magazines strayed to the question, which twin aged more? It only considered the speed effect, which is the smaller of the 2 effects. Well, your phone's GPS receiver doesn't need to compute the gravity effect because it's the same for everybody. It only computes the speed effect, and this is a possible source for this confusion. Now, if you couple a misconception with a little logic, you can be led to astoundingly bad conclusions. These issues can be difficult for people to overcome, but this is part of the process of discovering new truth. When I write this segment, it's research. I try hard to avoid wrong results. I stick to good sources and I limit guesswork. And that is term of the month, aging slower. Back to you, Don.
Thanks, Stephen, and welcome back. We're here with Tom Harbin, known as the Astro Canuck, and we're discussing astrophotography. Now, Tom, what are your experiences with light pollution where you are? I know here in Southeast Michigan, it's a big issue, but it may be a little different where you are. Can you tell us about that?
Well, I'm just outside of Toronto. I'm in the Greater Toronto area, and we're basically looking at a white zone on the Bortle scale. If anything, I'm classed as a Bortle 8 where I'm currently living, and I've experienced a fair range in the light pollution levels. Living out in the United Kingdom, there was a greater opportunity for less travel to get to some darker skies, but there's always the clouds. The United Kingdom is always famously known for the rain, but I felt I had enough clear skies to get enough out of that system, and I had lived in a Bortle 5, probably edging on a 6, and it was interesting when when I was imaging, and at midnight they would turn off all the streetlights in my town, which is really cool, and I was really appreciative of the council for doing that. And you could notice that if you took an image at 11:59, the exposure finished at 11:59, you would start at midnight, and you would notice a very, very severe difference in the quality of the images, where a little more of the fainter stars were just a little bit brighter, because you're getting rid of so much of the unnecessary light, and especially if you're only using like a broadband filter. So you're still letting in a lot of the external sources of light coming in. It can be tough because you want to be able to get as much time in for your images. You want to get as much integration as you can to get those details. I've also lived in a Bortle 3, which is I can barely even compare to what I've been able to see. Like walking outside, not even being dark adapted, and starting to see that little bit of the band of the Milky Way. And that was an amazing sight to be able to see. At that point, it almost feels like you have an unfair advantage, especially if you're even using a monochrome camera, because it's like every image just looks so nice. There's no, especially when you don't have any neighbors. That was a big thing. There was nobody having any floodlights, no security lights turning on. And obviously I prefer a Bortle 3, but we have filters that we can utilize now to cut out so much light pollution. It's not that much of a factor anymore.
That's true. You can get the narrow band filters that will help remove that extraneous man-made light. So, as you've been doing astronomy and astro imaging, both here in North America and in the UK, what have you encountered as far as, say, a mental block, a roadblock, if you will, or even burnout? Is that more self-imposed, or is that because of some of the limitations with equipment? Can you talk to our viewers about that?
Well, I'll use an example of what I personally had experienced. It was at the beginning the beginning of the lockdowns in the United Kingdom. We had a stretch of clear skies that was 2.5 weeks. Every single night was clear. Every night I'm thinking, it's clear again. All right, let's image. Let's get the telescope out. And it got to the point where I felt like I was, because I really like to tour around the night sky. Like I will take a few images, look at this target, and move to another one. And the way my backyard was set up, I only had a small window out toward the east, so there was a few targets I could get. And it was the same thing over and over again, but I wanted to be able to see more. It felt like I was doing the same thing night after night. And I was thinking to myself one night setting up and thinking, can I just go inside and not sit outside? And I thought afterwards, I was just wondering, like, why am I thinking that? I love doing this, but I was up late every night. And that's the other thing, is just not always getting on a proper sleep schedule with doing astrophotography. Is at least being kind to yourself and acknowledging that, sometimes we just don't image every night as much as we want to, it can unknowingly start to take a toll, which was surprising to me because I didn't think it would happen. And it was one of those things to kind of take that step back, be happy with whatever data I was utilizing, and then just kind of go from there. Later on, we did have like another month of clouds, so at least that was a bit of a break.
Now, yeah, with those 2 weeks of clear skies, you would think you'd be like the kid in the candy store, what else can we look at? But if they're continuous and you can only look towards the east, I assume you had buildings or trees blocking your view, the sky wouldn't really change all that much, even if you were staying up all night long to see what else was coming up over the course of an evening.
Yeah, that was always difficult. It was at least I could plan. At least I did. I knew what was going to be coming up, but it was very dependent on the seasons. So I really had to wait for those other targets to kind of come around to the eastern portion of the sky, or they would I end up missing them because southern targets, my neighbor's house was blocking, and the neighbors didn't take kindly to me offering to bulldoze their house. So I had to figure other means.
Yeah, I would think that would be a non-starter for sure. Now, in the few minutes that we have remaining, why do astronomy? Why do you do astronomy? You mentioned at the beginning that you had an interest from your background in graphic design, but can you expound on why you do astronomy, or why should anybody do it?
I've said this before, that astronomy, that space can blow my mind on a regular basis. Realizing after what we're looking at is certain targets are thousands of light years away, millions of light years away, and it's taken that much time for the light to reach us. And if you look at a galaxy that is 65 million light years away, that light left that galaxy, those photons traveled at the time of the dinosaurs. And it's those incredible facts that sound sometimes outlandish, but it's just the fact of science and physics that we get to see these objects, that we have this equipment available, we have the knowledge that's been acquired over the years, and the fact that we're still discovering new things about our universe, about our local galaxy, about our galaxy groups, with backyard astronomy, having this access to the night sky and fulfilling that curiosity has always been something I've wanted to do, because looking through a telescope is awesome. It's fantastic. I never would fault anyone for doing visual astronomy. Planets are better visually, but for taking a picture of outer space and sharing it with someone had been the catalyst. When I was looking through a telescope, held my mobile phone up to the eyepiece, took a picture, and I wanted to share it with more people. And there are a lot of people who don't have the opportunity to get these images. Perchance they are in a very highly polluted area, or there are enough obstructions that it's just not feasible for them to have any kind of setup to use. So I do astronomy so that I can share it with others, that I can have other people have their minds blown as well in some way, shape, or form, to create this little bit of excitement and realizing that you don't need a $10 billion telescope to see something really cool. You can do it in your own backyard.
Very true indeed. Even though we all do own the Hubble, but I like to tell folks that's my scope too. But Tom, I want to thank you very much for taking time out of your schedule to be a part of our program. For our viewers, please visit the club website, the address down at the bottom of your screen. And to finish out the program, as always, is Stephen with What's Up in the Night Sky.
Thanks, Don. What's up in the night sky for February 2023? Days are getting longer in the Northern Hemisphere, shorter in the Southern Hemisphere. February 2nd is Groundhog Day. This is a cross-quarter day. That is, it's halfway between the solstice that we just had and the equinox. There are 4 of these cross-quarter days every year, and what do they mean? Not much. February has a full moon on the 5th, third quarter on the 13th, a new moon on the 20th, and first quarter on the 27th. Apogee is on the 4th, so the February 5th full moon is near as small as it gets. Apogee is farthest from the Earth. Then we have Mercury shown here on the 1st of February, an hour before sunrise. Mercury goes from Capricornus to Sagittarius over the month and rises anywhere from about half an hour to an hour before sunrise. It is best at the beginning of the month. Now, aphelion, when Mercury is farthest from the Sun, is on the 15th. But it is better to see on September 1st because it is a larger angle between Mercury and the Sun on the 1st. It's a geometry thing. Then on February 10th, we show Mars, Uranus, Jupiter, Neptune, and Venus. And this is just an hour after sunset. Mars is in Taurus and sets after midnight, approximately. It is best at the end of the month. Now, there's a comet that I'll be talking about near Mars here on the 10th. So on the 10th, you could take a look. Jupiter is in Pisces and sets between 4.5 and 2.5 hours after sunset. It is best at the beginning of the month, that's Jupiter. Saturn has superior conjunction February 16th, so this is not shown. It's behind the Sun. Uranus is in Aries and sets near midnight. Neptune is in Aquarius and sets 3 hours after sunset. Then it gets worse. It's best at the beginning of the month because superior conjunction is coming soon on March 15th, so next month. And then we get back to the comet. So we're still here on the 10th. Comet C/2022 ZTF is closest to the Earth on February 1st at only 0.28 astronomical units away from us. And then over the rest of the month, it dims as it heads away from the solar system, where we won't see it again for tens of thousands of years easily. But near Mars on February 10th, so you can just look up at relatively bright Mars and take a look. And that's what's up in the night sky for February 2023. Remember, we don't charge money for this show, but we may tax your brain.